Lesson 2-1. Let's first do a pre-activity where you stop the screencast and review some material that we've talked about before. And here are the answers. One more time, stop the screencast, see if you can do these two problems. And here are the answers. 2-1, relations and functions. Objective, analyze relations of functions, use equations of relations and functions. Let's take a look at a relation. It's a set of ordered pairs. The domain of a relation is the set of the first coordinates, the x coordinates, and the range is the set of the second coordinates, which are called the y coordinates. So the domain can be written out as this way. It's all the x coordinates here, and the range is all the y coordinates. Let's take a look at what it looks like in terms of a mapping. So we can show it in terms of ordered pairs. We can show it in terms of a table. We can show it in terms of a graph, graphing all these ordered pairs. Or we can show it as a mapping, where the 1 maps to the 2, the -2 maps to the 3, and so on. When this happens, when every x goes with one y, we call this a function, because it's paired with exactly one element of the range. Let's take a look at these problems and see what we can do here. It says to state the domain of each relation, then determine whether each relation is a function. So the domain will be all the x coordinates, 10, 6, 7, -8. And the range will be all the y coordinates, 3, -2, 4, -9. And since every element of the domain, there's only one corresponding element of the range, so this relation is a function. Now let's take a look at this. The domain will be -3, 0, 1, and 5. And the range will be -4, -2, 0, and 2. Now, because 0 is paired with two values, this is not a function. Let's go to this one. The domain is 1, 2, and 3. The range is 3, 4, and 7. We don't have to mention the 4 again. Now, because 1 is paired with 2, this is not a function. Now, the domain are all the x coordinates, -1, 0, 1, and 4. And the range are all the y coordinates, which is -1, -3, 0, and 2. And this is a function. Every x goes with one y. Determine whether the relation is a function. Just a function, we don't have to worry about domain and range. And so I'm looking at every x, and I see this x is 5, and this x is 5, and it has two different y's. So this is not a function. I'm looking at all my x's. They're different, and they go with different y's. Every x has only one y, so this is a function. Is a function. Let's take a look at this. Every x has only one y. Is a function. This x has three different y's, so this is not a function. Every x or input has only one output. A visual way to tell whether something is a function is what we call the vertical line test. If you can draw a vertical line anywhere on the function and only one x matches with one y, then we say it's a function. Now you can see this x has two different y's, so that's why we say it is not a function. Let's see if we can determine whether this is a function or not, and the answer is no, and the reason why is because the number 5 has two y's going with it, and so does the number 2. Is this a function? The answer is yes. Every x has only one y. Every x has only one y. So let's take a look at these again. Now this is a set of just points here. Every x has 1 point, so this we say yes, this is a function. This one, yes, this is a function. Every x has one y, and the answer is no here, because for this x, there are two different y's, so the answer is no. This x has two y's. And the answer right here is yes, every x has one y. It passes the vertical line test. Your turn. Pause and see if you can answer this question. And here's the answer. Let's talk about some of the graphs we saw were what we call discrete relations, and they are made up of individual points. And then there's another kind of relation called continuous, where it's a smooth curve or line, and that's a continuous relation. Okay, sometimes in problems we have what we call a discrete, and this is a graph shows the length of the Tour de France kilometers each year from 2000 to 2009. So we call this discrete because there are no values between 2000 and 2001. Now this is also a function because it passes the vertical line test. Let's go ahead and graph y equal to 3x minus 1 and determine the domain and range, then determine whether the graph is a function. So let's go ahead and graph some points. If I put -1 in for x, I will get the number 2. If I put in 0, I will get -1. If I put 1, I'm sorry, I have the incorrect answer here. If I put -1 in here, I'm going to get -4. Put a 0 in here, I'm going to get -1. Put a 1 in here, I'm going to get 2. Put here, and then that'll be a 5. I'm going to go ahead and graph those. -1, 1, 2, 3, 4. 0, -1, 1, 2, and 2 is 2, 3, 4, 5. So we have a line. Okay, now let's talk about the domain, and the domain is all real numbers. We can use any x we wish, and the range is all real numbers. We're going to have all kinds of values for our y, and yes, this is a function that passes the vertical line test. Every x has only one y. Your turn. Pause. And here's the answer. The domain will be similar to what we had before. The domain will be all real numbers, and the range will be all real numbers. Independent variables are what we call x, and y is dependent on what x is. This is important because when we talk about function notation, then we can find the dependent variable by substituting the independent variable. So we're going to take our equation that we usually see in y's and x's, and we're going to convert the y into f of x. So the y is dependent on x. And the nice thing about this notation is then we can put in the independent variable like -6. So f of -6 means substitute -6 into the relationship to get the answer. All right, in this problem we're going to find f of 6. 6 is the independent variable. That's what we're going to put in for x, and this is the answer we get. You can put in 2y into the input value, 2y here, and everywhere there's an x you're going to write 2y, and you're going to simplify using PEMDAS. So let's go ahead and do this problem. I am going to substitute 2.8 into this relationship. And then I'm going to multiply and get an answer. I'm going to show you how to use your calculator to help you. So I'm going to actually put in 0.5 x squared, and I'm in the y equals screen, minus 5x, and then plus 3.5. So I've written down my g of x. I know it says y sub 1. Then I'm going to do second, quit. And then I'm going to go to vars, and then I'm going to go to the menu y vars, and then I'm going to press enter, and then I'm going to press enter again, and it's going to paste y sub 1. I'm going to put a parentheses, and I'm going to put the 2 6.8. And the calculator will put 2.8 wherever there's an x. And so my answer will be negative 6.58. So this is a way to use your graphing calculator to evaluate this. Now your graphing calculator will not help you on this when you substitute 4a. So let's go ahead and do that. 0.5, and then we're going to put 4a to the second power minus 5 times 4a plus 3.5. So this is going to be 0.5, and remember PEMDAS, we're going to do powers first, so that's going to be 16a squared minus 20a plus 3.5. Now 0.5 times 16, that's a half times 16, that's 8a squared minus 20a plus 3.5. And this is all we can do. You cannot combine these because they are not like terms. All right, your turn. Pause. And here's the answer. Pause. And here's the answer. Pause. And here's the answer. Pause. Find the error. And here's the answer.